Electric current I is given by the formula I equals to A and VQ. What do each of the symbol represent for electric current in the metal wire? Alright, so the equation that we have for the current in a conductor is A N Q V. Alright, let me confirm here. Yeah, A N Q V. Now, this is a general equation if you want to compute the current that is flowing through a conducting wire, right? So this is our conductor, and it got free electrons, and it got a cross-sectional area A, and there is a drift velocity V, and the charge on each electron is Q, and N, the amount of, I will tell you what is N. Alright, so it's a general formula to compute the current in a metallic wire, right? So remember that it's important to consider each and every factor. Okay, so each and every factor, either it is A, N, Q, or V, all of these factors are contributing to the value of the current, okay, in that metallic wire, in that conducting wire actually. So the drift velocity is the velocity of the electron, the average velocity of electrons moving, because primarily current is the flow of electrons, right, or the flow of charge. So the electrons moving and their velocity, their drift velocity is just the average velocity of electrons, because electrons are like, so imagine I have this much electrons with me, and they are in their random motion, so one will be going like this, or it could be like this. So their average velocity is known as the drift velocity, right? So we know that it is a contributing factor in the current, right? And it's directly proportional to current. So if we increase the drift velocity, the current will increase. Similarly, Q is the charge on each electron, right? Charge on each electron, we know that it is 1 point. It is the charge on each electron. It is a constant value, right? So this is a constant for us, and N is a very important factor. See, in every conductor, so imagine two different conductors. So imagine this is a gold, and or let's say this is a silver. This is a silver, and we have another material, another metallic wire which is made up of copper, right? So which one do you think is a more efficient conductor? Of course, copper. Why? Because copper got more number of free electrons per unit volume. All right. So there would be more number of free electrons in copper than in silver, and that is what N represents. N is the electron density. All right. N is the electron density, and is, of course, it is a contributing part in, and it's directly proportional. The current is directly proportional to the electron density in that particular material. Lastly, we have A, and again, current is also proportional to A, and A is just the cross-sectional area of the wire. So the thicker the wire, the more will be the current, right? The thinner the wire, the lesser will be the current. All right, so now we got the idea what A and Q and V are representing. Let's just compare and see which option is actually correct. So option A is area of cross section. Yeah, that is right. Number of free electrons, not actually, that is not. So this option is, we cannot go with this option because N is not representing the number of free electrons. It is actually representing the number of free electrons per unit volume, right? It's an electron density. So we got N wrong, so we can move to the other option. So option B is area of cross section, right? N is number of free electrons per unit area, right? V is average drift speed of free electrons. This is right because it's the average drift speed. And the charge of each electron, Q. Yeah, that is right. So yeah, no need to actually look for other or analyze other options. We're good to go with the option B. Why? Because they all are satisfying our definitions for these four variables, right?